I welcome you all for the lecture 15, Enriched Vermicompost Production Technology. So, last lecture we have discussed about the conventional vermicompost production technology, that means the use of the waste materials, structure of the beds, mixing of the waste materials, and this process of maintenance and harvesting of vermicompost for the conventional vermicompost production. So, today we will be discussing about the enriched vermicompost production technology, that means when there is a need to increase food grain production to meet the demand of the growing populations, how we can enhance or improve the quality of the organic manures, so that they can meet the nutrient requirement of the crop. So, as you know, we discussed also earlier classes. So, the number of peoples they are going to be increasing with the hungers, adding the hunger populations in the 21st century. If you see the sub-Saharan Africa, so currently around 250 million populations at the risk of hunger. This is going to increase by up to 350 million. Similarly, in Asia, currently 200 million populations at the risk of hunger, or as you say food insecurity, and this population is going to increase up to 250 million by 2025. So, there is a need to increase the food grain productions. The options for the chemical farming, as you see, so there is increase in the use of the nitrogen and phosphatic fertilizers. Also, there is increase in the exploitation of the groundwater, that is irrigations, and also increase in use of the chemical pesticides. However, the food productions has recent years is either constant or in somehow decreasing trend. This is due to the soil erosions and the salinity and frequent use of the fertilizers and the pesticides and the increasing cost of the productions and the environmental pollutions increasing the global warming. So, to avoid this, as we are discussing, so organic farming is one of the options, the key candidate how to maintain the food grain productions or the improve the food grain productions in a sustainable environment. So, for this organic farming we need to make the value additions, and that means we have to increase the contents of the nutrients in organic manures by adding the nutrients or the by the natural sources or from the biological sources. So, if you see the sources of why the enriched vermicompost is required, why do we need for the enrichment of the vermicompost? Because in general the organic manures like the farm yard manures or the compost or the vermicompost, they contains on an average 0.5 to 1.5% nitrogen, 0.2 to 0.8% P2O5 and 0.5 to 1.2% K2O. And this is so small amount of nutrient contents in the organic manures, and if you apply very less amount of the low dose, so they may not meet the nutrient demand of the crop. So, that is why we may not be able to meet the production levels with such organic manures or the conventional manures which contains less amount of NPK and other nutrients. For example, you can see if for a particular crop if you supply 100 kg nitrogen per hectare to get the maximum productions from that. Suppose example rice crop, for a medium fertile soil usually recommend around 100 kg nitrogen per hectare, that is through chemical fertilizer. And if the same 100 kg nitrogen if you want to supply through organic manures which contains very less nitrogen, around 0.5 to 1.5% nitrogen, you need around huge quantity of organic manure, that is 7 to 20 tons per hectare. So, the availability is makes a question, because whether we can supply huge amount of organic fertilizer to meet the nutrient demand of the crop. So, you need 7 ton per hectare if the nutrient content, the N content is 1.5%. So, in this case if you enrich the compost with nitrogen, if somehow we can increase the nitrogen content up to 3%, then we can minimize, we can reduce the compost requirement up to 3 to 3.5 tons per hectare. So, that is the purpose why you go for the enrichment of vermicompost. By the way, you can minimize the requirement, at the same time we should maintain the production levels, so that we cannot sacrifice the loss of production. So, these demerits of manures can be overcome to certain extent through preparation of enriched vermicompost, as you say, by adding natural or the biological sources of nitrogen, phosphorus and the potassium for improving the quality of the vermicompost. Or moreover, the waste with a different nutrient rich substance opening a new direction of the technological upgradations for improving the quality of the vermicompost or the nutrient status of the vermicompost. In modification of vermicompost is done either by microbial enrichment or by fortifying with the natural rock minerals and the agricultural waste. They are rich with specific nutrients. So, those materials can be added in the vermicomposting process, so that we can increase the value or the nutrient content of the vermicompost to meet the demand of the crops and to attain a particular production level. So, these are the figures we are showing how the advantage of having the enriched vermicompost, because we are having the enriched compost or the enriched vermicompost, we can have the more productions, more fruits or more plants. So, we can have a better disease control, and this is this contains the enzymes and the plant growth regulators and the hormones also there, because as we are working with the worms, earthworms are present in the earthworm body secretions, they contain many enzymes, vitamins and the hormones. And also the quality of the product, that is better with the enriched compost, and the larger size of the fruits or the vegetables, that increase the size with the better quality of the vermicompost, and there is a increasing the population of the microbes, and we can have the faster growth rates and the higher concentration of the microorganisms present in the soil. They can make the soil fertility, they can keep the soil fertile for long run. If you see the nutrients, natural sources of the natural sources contains the nutrient enrichments. So, those are some of the examples of the either nitrogen enrichment or the phosphorus enrichment or the potassium enrichment or calcium, magnesium. What are the natural sources available which can be mixed with organic waste for increasing the nutrient contents. So, for nitrogen, the natural sources are the oil cakes like your mustard cakes, which contains around 5.3% nitrogen, and the groundnut cake around 7.3% nitrogen, neem cake 5.2% nitrogen, karonja cake 3.9% nitrogen, sesame cake 6.2% nitrogen, and castor cakes 4.3% nitrogen. So, these oil seed cakes, those after the extraction of oils, these oil cakes can be used in the vermicompost pit for increasing the nitrogen contents of the vermicompost to have a enriched vermicompost. So, in addition to this also we can use the other sources like poultry manure and the azolla, the aquatic farm, the green manure crops or the waste from the leguminous crops. So, those have the high N content, those materials can be added in vermicompost pit to have a higher N content. So, similarly, the sources of phosphorus, you can have the rock phosphate that contains around 20 to 40% P2O5, bone meal that 20 to 25% P2O5, or the basic slag that is 17 to 20% P2O5, or the horn and hoof mills, and waste from the fish and the animal processing industry. So, those waste also can be added during the composting process for phosphorus enrichment. For enrichment of potash, we can use the sylvite that contains a high concentration of K2O, that is 63% of K2O, wood ash, that is the eucalyptus that contains 5.9% K2O, casuarina wood 1.5% K2O, tobacco stems and also bubble wood, those can be added during the composting process, so that we can have a higher potash contents. For the calcium and the magnesium enrichment, so natural minerals like limestone, gypsum and dolomite, those materials can be added for the calcium and magnesium enrichment, and this enrichment of vermicompost can be done by either addition of rock minerals during the composting process, or we can have the addition of these minerals with the ready-made compost. So, if you see the preparation of this enriched compost, as we discussed the last class, the preparation of the normal compost, we use the agricultural waste, that is aquatic weeds, or the agricultural waste means the rice straw, the wheat straw, the crop residues can be mixed together with the cow dung. Cow dung is the slurry we can mixing as 30 to 70%, 30% minimum, and as per the availability we can go up to 70% this share of cow dung. This cow dung and this the waste slurry can be prepared, and those slurry is loaded in the vermicompost bed as we discussed last class. And for the preparation of enriched vermicompost, after addition of this waste and the cow dung mix in the vermicompost bed, then either we can add the rock phosphate as a natural rock minerals, or we can add the microbes in the compost bed, or both can be added together, the microbes and the rock minerals that can be those materials can be added in the compost pit. Then the normal compost processing goes on as we discussed last class as remains same. Only thing this process after the mixing of the waste materials with the cow dung slurry and adding in the vermicompost bed, after that step if you are going for the enriched compost production, then at this stage we can add either the rock minerals or the microbial inoculants, these natural sources or the biological sources which are used for the enriched vermicompost productions, those materials can be added at this stage immediately after loading of this the waste and the cow dung mix in the vermicompost bed. So, the microbes which are used for the enrichment of the compost. So, these are the microbes, I can say the left hand side. So, these are the microbial inoculants. So, the one is Trichoderma viridi. Trichoderma viridi is a cellulolytic fungus. So, that is used for the early decomposition or the quick decompositions of the cellulose present in the organic waste. And the second one is a Azotobacter crococum. This is a nitrogen fixing bacteria. By adding this Azotobacter crococum, it can enhance the nitrogen mineralizations and the nitrogen contents of the vermicompost. Third one is a Bacillus polymixa. This is a phosphate solubilizing bacteria. So, by adding these microbes in the compost bed, it can make the better solubilizations and the better availability of phosphorus from the compost. And the fourth one, Bacillus firmus. So, this is a potash releasing bacteria. By having this bacteria, the microbes in the compost preparations, so this can have the better mineralizations and the better availability of the potash during application to the field. And the other case, we can add all the Trichoderma viridi, Azotobacter crococum, Bacillus polymixa and Bacillus femoris. This the cellulolytic, nitrogen fixing, the phosphorus solubilizing and the potash releasing bacteria all can be added together in the composting beds. So, this is the microbial inoculations and the amount is 50 ml broth per kg of organic waste. Similarly, we can add also the rock minerals in the compost bed. The rock minerals we can for the phosphorus enrichment or the calcium magnesium enrichment or the potassium enrichment. For phosphorus enrichment, the rock minerals used, that the rock phosphate. In the rock phosphate, the total P content around 8.5%. For the calcium and magnesium enrichment, we use the dolomite. Dolomite contains total calcium 19.25% and the total magnesium 12.8%. For the potash enrichment, we do add the mica that contains 10.12% of the potash. And these are the available phosphorus from this rock phosphate around 35.2 ppm and available potash from the mica, that is 140 ppm. And the nitrogen where is Nd, that is not detectables. So, these are the enrichment materials, the natural minerals, that is either rock phosphate for the phosphorus enrichment, for the dolomite for the calcium and magnesium, or the mica for the potash enrichment. Those minerals can be added during the after loading of the organic waste and the cow dung mix in the vermicompost bed. And we have tried different doses of these rock minerals starting from the 5% to 30%, and we will discuss what the effect of these rock minerals additions at different doses on the quality of the final vermicompost. So, if you see the quality in terms of the organic carbon and nitrogen contents of the final vermicompost that we make ready. So, after 2 months or the 60 days of the composting process, we see the effect of different organic waste and microbial inoculants on organic carbon and nitrogen contents of the vermicompost. So, here we have taken 3 organic waste. So, number 1 is your the water hyacinth, that is WH, and the second one is the paddy straw, that is a PS, and the third one is the sawdust, that is SD. And we have used all the microbial inoculants as we discussed previous slides. So, these are the Trichoderma viridi as given TB, and this Azotobacter coccocum, AZC, phosphate soluble bacteria, that is a Bacillus polymaxa PSB, and potash releasing bacteria, that is Bacillus firmus, that is KSB, and mix means that is a mix of all the 4 microbes TB, AZC, PSB, KSB, that is a mix where all the 4 microbes are mixed together, and Cl is the control, is the normal vermicompost, conventional vermicompost without inoculation of any microbes. So, see the effect of these waste materials and the microbial inoculants on the organic carbon content. You can see here that as we go on, is a control means there is no addition of the microbes, the organic carbon content is around 406 milligram per kg, that means 40.6%. As you go on adding the microbes, the organic carbon content of the vermicompost that goes on decreasing. So, when you go for the lowest organic carbon content is noted as a 313 milligram per kg, that is 31.3% when all the microbes they are mixed together. So, that it indicates that, so addition of microbes that facilitate better decomposition of the crop residue, and that so the organic carbon content is reduced. That means the compost, when there is a decomposition, that means the compost is ready for application to the soil for better availability of nutrients. If the organic carbon content does not decrease, it indicates that, so there is very poor decomposition, that means there is not a well decomposed manure, and once if you apply the well undecomposed manures or not well decomposed manures to the field, so it may not supply the nutrients at the required amount for the crops, and it may not meet the requirement of the crops, hence have the lower productions. To have a high production, then we should use well decomposed compost in the field. So, in this case we can see by adding microbes, it can decreases the organic carbon content, that it indicates that the waste materials is well decomposed by inoculation of the microbes. And similarly, if you see between among the waste materials, the organic carbon content is the lowest in case of water hyacinth, and among the all 3, and the highest in case of the sawdust. That means the sawdust contains the high cellulose, high carbon content, and the decomposition, because of low nitrogen content in the sawdust, the decomposition process is very slow. Here the carbon content is around 52.7% in sawdust, whereas the water hyacinth is around 24.3%. So, this indicates that the sawdust is not well decomposed within 2 months. It may take more time for decompositions, or we have to add more and more microbes for the better decompositions, whereas this the water hyacinth organic waste, so that is well decomposed, the carbon content is around 24%. Similarly, if you see the nitrogen contents as influenced by the different waste materials and the microbial inoculations, as the organic carbon content decreases, the nitrogen content increases with microbial inoculation. That means, with inoculation microbes, there is a better mineralizations, and the N contents of the vermicompost is increasing with addition of the microbes. And if you see, if you are adding the Azotobacter coccocum, this is a nitrogen fixing bacteria. By adding AZC, the N content of the compost is increased by 58%. That means, from 10 milligram per gram to 15.8 milligram per gram, or from 1%, it has increased to 1.6% in case of the Azotobacter coccocums. The increase over the control is around 58%. Similarly, if there is addition of all the microbes, the nitrogen content is 1.7% or 17 milligram per the gram of the compost, and the enhancement is around 70% as compared to without microbial inoculations. And if you see the among the waste materials, the water hyacinth has the highest N content, that is 1.9% or 19.4 milligram per gram, and lowest is in sawdust. And as you have discussed in the previous classes, for a good vermicompost, this CN ratio should be between 10 to 20:1. If you think of the organic waste water hyacinth, here the carbon content is around 24% and the nitrogen content is around 1.9 or 2%. If the CN ratio of the organic waste based vermicompost, this is around 12:1. So, this indicates that, so this is a how the waste resources, the waste materials influence has an impact on the quality of the vermicompost, and the sawdust, if you see the CN ratio of the sawdust based vermicompost is 52% or the 53% of carbon and 3% 0.3% of the nitrogen. So, this CN ratio may be more than 100. So, this is not, that means it has not, it is not well decomposed. It may take more and more time for decompositions to make it ready for the field level applications. So, this is how the microbial inoculations or the inoculants they can increase the value, they can increase the nutrient content of the vermicompost by adding in the composting bed. Similarly, if you see the effect of the different those organic wastes and the microbial inoculations on the phosphorus and potassium content of the vermicompost, we can see that when we are mixing all the microbes together, the phosphorus content is increasing by 43% over the control where no microbial inoculation was done. Similarly, for the potash, by the potash content is increased by 45% over no microbial inoculations in the control as controls. So, there is around 45. So, almost more than 40% increase in the phosphorus and potash content with microbial inoculation as compared to without microbial inoculation. And this is happened because of the earthworm growth rate. So, by addition of the rock minerals, the earthworm growth rate also changes. So, you can see here the effect of rock mineral doses and microbial inoculations on earthworm growth rate. And the three rock minerals on the rock phosphate, dolomite and mica. So, the x axis shows the increasing doses from 0 means there is no addition of 0%. So, it is a conventional compost, 5% of rock minerals, 10%, 15, 20, 25 and 30% rock minerals added based on the dry weight of the organic waste. And this is the y axis shows earthworm growth rate, and you can see for the rock phosphate the no addition, and with the addition of rock phosphate up to 20% addition Rp20, there is somehow increase in the earthworm growth rate, that is milligram of increase in biomass per worm per day. If you go on increasing the rock phosphate dose beyond 20%, the earthworm growth rate is significantly decreasing. And if you see for dolomite also, dolomite the earthworm growth rate increases with increasing addition up to 15%, and beyond 15% any further increase in the addition there is a significant decrease in the earthworm growth rate. And if you see the mica waste, so mica waste also see that from the very beginning or from 0, if you go on adding mica waste, it does not increase the earthworm growth rate, rather there is a decrease. If you increase the mica beyond 10%, up to 10%, it remains almost constant. After 10%, if there is any further increase in the mica dose 15%, so there is significant decrease in the earthworm growth rate. So, that means shows the rock minerals either the 10 or the 20% mica or the DM 20. So, there is a earthworm growth rate increases. So, after that there is a significant decline. So, the earthworm the workforce, so more earthworm population that causes the mineralization process and the decomposition of the waste materials. So, earthworm growth rate should be well maintained for better quality of the vermicompost. And if see the effect of this rock minerals on total phosphorus content the vermicompost during composting process, as you see the rock phosphate as is used as a source of phosphorus. If you go on adding highest dose of rock phosphate, so there is a higher content of the phosphorus in the vermicompost total phosphorus. So, 3.5% with the Rp30 if you add 30% rock phosphate. If you do not add conventional vermicompost, total phosphorus is 0.9%. However, it's the picture is not same for the Olsen phosphorus or the total phosphorus. If you see the picture for the Olsen phosphorus, Rp30 does not give the highest or the available phosphorus during the composting process. We have seen the different days of composting as the days passes. So, there is a increasing phosphorus availability in the composting process, and the maximum availability is noted in Rp20, that 20% dose of rock phosphate, not the 30%. If you increase the Rp doses or rock phosphate doses beyond 20%, so there is a decline in phosphorus availability in the composting process, and this can be attributed to the earthworm growth rate. As there is a decrease in earthworm growth rate with higher dose of rock phosphate, that causes the less decompositions or of the waste materials with increasing dose of RP, and RP dose 20% is found to the best the optimum dose for this enriched vermicompost. Any further additions that may cause the decreasing phosphorus availability during the composting process. And similarly, if you go see for the total potash content, if you see the mica dose, mica is responsible for potash, increasing dose of mica that increases total potash content. So, as we go for the highest mica dose 30%, mica 30, that gives the highest potash content of 3.46% at the end of the composting periods, and 1.67% where without any addition of the potash. But if you see the picture for this available potash, or you can say the ammonium acetate potash content. So, here the mica 10, the mica dose 10% mica, that gives the better result, best result as compared to other doses, because if you see the mica additional mica more than 10%, that decreases the earthworm growth rate. At the same time, the release of potash in the composting bed or availability of potash, that also decreases during the process of composting with the addition of mica higher than 10% doses. So, from this we can see that, so mica 10% doses and the rock phosphate 20% and the dolomite gives the 15%, that seems to give the better results in enhancing the phosphorus, potash, and of course, the nitrogen content of the vermicompost. And of course, you see the other contents like the microbial activity. This also you can see with increasing dose of the rock minerals. These are the dose of rock minerals, either the 0 means no additions, 5, 10, 15, 20, 25 and 30% of the organic waste the rock minerals are added. So, this first bar diagram show the rock phosphate, the second one is for this dolomite, and the third one is for the mica. So, in this case also this is the we are seeing the effect of this rock mineral doses on urease activity and the acid phosphatase activity in the vermicompost. As you see the final vermicompost is analyzed for the final vermicompost, you can see if you go on increasing the RP doses up to 10% or 15, 10, 15, that gives the maximum. After that, there is a decline in urease activity, and same also for this acid phosphatase activity. Whereas the dolomite doses, it can go up 15%, that shows up to the better results. After that, there is a decline in the urease and also acid phosphatase activity. Whereas mica, even if the addition of the mica even 5% or the 10%, that causes the decrease in the microbial activity in the vermicompost. And if you see the keeping quality of this vermicompost, the storage. So, as you go on storing the vermicompost, what is the change in available nitrogen, phosphorus and potash content of vermicompost during storage? As you go on storing, you can see the available nitrogen, the first figure, the middle one is the available phosphorus, that is the Wilson phosphorus, and the third one is the available potash content. So, we analyze the available N content. So, this figure shows every 15 days the samples were taken from the bags, from the storage bags, and the analyzed for the availability of nutrients during the storage of the normal room temperature. So, I can see for this available nitrogen. So, dolomite 15 gives the best result, where the nitrogen for all the vermicompost that increases up to 90 and 105 days, then decreases thereafter. And dolomite dose of 15% and 5%, they give the best results of the higher available nitrogen with the higher doses of the dolomite or other dose RP or the mica, there is a less nitrogen content. And if you Wilson phosphorus increasing the as RP 15, rock phosphate 15, that gives the best results, because Wilson phosphorus that goes on increasing up to 90 days and thereafter it remains almost constant. Unlike nitrogen that decreases, nitrogen after 90 to 105 days the available N decreases in the compost during the storage, whereas the phosphorus and the potash both they remains almost constant after 90 days, they increases up to 90 days, thereafter the value remains constant. But nitrogen there is a loss either through volatilizations. So, the loss of nitrogen, the available nitrogen lost during the storage. In case of the Wilson P or the available phosphorus RP 15, that gives the maximum available phosphorus content during the process of composting, followed by the RP 5, the 5% rock phosphorus dose, that gives the maximum available, and where there is no application control gives the lowest one. Similarly, in the mica doses we can see the mica 15 that gives the best results, followed by mica 5% and the mica 30% for increasing the potash content during the storage. It increases and up to 90 days, and thereafter it remains almost constant. So, this is how the storage life you can see here, that if you want for storing of this compost, how long you can store without deteriorating the quality of the produce. You can see up to 90 and 105 days it can be safely stored in a normal room temperature, and within that period it must be applied in the field for their better use. So, with this you can see the take home message. You can see the waste resources, water hyacinth and paddy straw having low CN ratio, that is around 48 to 67:1, enhance the growth rate and population of earthworm, thereby resulted better quality of vermicompost with respect to chemical and biochemical properties as compared to the waste sawdust. The sawdust has higher CN ratio 366:1, which is quite unsuitable for the vermicomposting. It takes long time for the compost, and if you can add in the specific the celluloid fungus, they can have a they can cause a quicker decompositions, and they can decrease they can have a composting period can be reduced to 2 to 3 months, but however the as compared to sawdust, the water hyacinth and paddy straw seems to be the better materials, the best materials for the composting process, and those materials can be used for the vermicompost or any vermicompost production. Then as for the microbes, the combined application of microbial inoculants, that is your Trichoderma viridi, Azotobacter crococum, Bacillus polymexa and Bacillus firmus as the nitrogen fixing, phosphate solubilizing and the potash releasing bacteria and the celluloid fungus. So, those can be added together. So, in the composting process, by that they improve the chemical and biochemical properties, like the increasing the microbial counts of BC as compared to the conventional BC beans without application of any microbes. The other one, in the vermicomposting process, use of rock minerals, that is rock phosphate at 20% and dolomite at 15% and mica at 10% with microbial inoculants, the inorganic waste, enhance the earthworm growth rate and improved the quality of vermicompost with respect to higher availability of micronutrients as we discussed. So, using those rock minerals in mix and along with microbial inoculation, they can increase nitrogen availability by 26% in the final vermicompost, phosphorus availability by 19% and potash availability by 10% as compared to the conventional vermicompost without application of any natural minerals or microbial inoculants. And the application of rock minerals, that RP or dolomite or the mica at 15% along with the microbial inoculants in the vermicomposting process increase significantly the biochemical properties like your acid phosphatase activity and urease activity as compared to the conventional vermicompost. And with respect to the shelf life, you see the shelf life of vermicomposting storage, it can be stored for 90 to 105 days in a safe. So, for storage for longer periods, reduce the microbial activity and the nutrient availability of the vermicompost. So, here we can say that by adding the different natural rock minerals and the microbial inoculants to the vermicomposting process, that means during the composting process, it can enhance, it can increase the nutrient content of the vermicompost. As we discussed, nitrogen content can be increased by 26% and the phosphorus by 19%, potash by 10% in the vermicompost. That means the availability, and also total NPK content also increased with the addition of rock minerals. So, by this, as you see, so enrichment, there is a scope. So, we can make the vermicompost enrichment using either natural minerals or the microbial inoculants, and you can improve the quality of vermicompost, which can be best suited or suited for the crop production. And also you can make the crop specific vermicompost, so that it can be sold, can supply to markets, can be reached the farmers, comfortable for the farmers. They can use for specific crops, specific type of vermicompost enriched with specific nutrients, so that we can minimize the need of the chemical fertilizers and we can attain the desirable productions without affecting or without harming the environment. Thank you very much.